All right, lesson 4 is all about dividing polynomials, and our lesson essential question is how can you divide polynomials? Here is our table of contents. Use long division to divide polynomials. So our dividend divided by our divisor equals our quotient plus our remainder divided by our divisor. Or our dividend, so the number that we're dividing into, equals our quotient times our divisor plus our remainder. So there's two different ways that you can write your quotient at the end. So step 1 is to set up like a normal division problem. So our dividend, my numerator, when I started it, goes inside the division sign while the divisor, my denominator, goes on the outside. If you are missing a term in your dividend, use a 0 as a placeholder. So if I had something like x cubed plus x, notice I went from x cubed to x instead of x cubed to x squared, I put a 0 in as that placeholder. 2 is ask yourself what times the divisor will give me the first term in my dividend. That number goes on top, so on top of the division. Then I multiply your divisor by your first term in your quotient, subtract, bring down my next term, and repeat this process until I don't have any more terms to bring down. If you get a 0 for your last term, you don't have a remainder. If not, you can write your remainder as a fraction using the remainder as your numerator and your divisor, the number you divided by, as your denominator.
All right, so we're going to divide x cubed minus 2x squared minus 3x plus 10 divided by x plus 5. So the first thing that I want to ask myself is x times what gives me the x cubed? Okay, so if I'm multiplying x times what gives me x cubed, in this case, x squared. So now I have to multiply that x squared times x plus 5. So x squared times x gives me x cubed, x squared times 5 gives me 5x squared. And then I subtract. X cubed minus x cubed is 0, negative 2x squared minus 5x is negative 7x squared. I bring down the negative 3x. Now I ask myself, x times what gives me negative 7x squared? In this case, negative 7x. I multiply negative 7x times x plus 5, which is going to give me negative 7x squared minus 35x. Again, I subtract. Negative 7x squared minus negative 7x squared is 0, and negative 3x minus negative 35x is 32x, and then I bring down my 10. Again, I ask myself, x times what gives me 32x? In this case, it's going to be plus 32. So 32 times x gives me 32x, and 32 times 5 is 160. Again, I subtract. 32x minus 32x is 0, and 10 minus 160 is negative 150. That's going to be my remainder, so I'm going to write it as negative 150 over x plus 5. All right, so we're dividing 4x cubed minus 3x minus 99 divided by x minus 3. The one thing that we can notice, however, is that we have an x cubed and an x, but no x squared. We need to include that x squared in order to be able to divide correctly. So what I'm going to do is I'm going to add a 0x squared in as a placeholder. So now I have 4x cubed plus 0x squared minus 3x minus 99 divided by x minus 3. I divide the same way I would normally. X times what gives me 4x cubed? In this case, 4x squared. 4x squared times x gives me 4x cubed, and 4x squared times negative 3 gives me a negative 12x squared. From here, I can subtract 4x cubed minus 4x cubed is 0. 0x squared minus negative 12x squared gives me a positive 12x. Then I can bring down that negative 3x. From here, I'm going to ask myself again, x times what gives me 12x squared? In this case, 12x. So I'm going to multiply 12x times x is going to give me that positive 12x squared, and 12x times negative 3 is going to give me a negative 36. From here, I can do 12x squared minus 12x squared. It's going to give me 0. And negative 3x minus negative 36x is going to end up giving me a positive 33x. Then I can bring down my negative 99 and again ask myself, x times what gives me 33x? In this case, 33 or plus 33 is going to give me that 33x. So 33 times x gives me 33x, and 33 times negative 3 is negative 99. Again, I can subtract. 33x minus 33x is 0. Negative 99 minus negative 99 is also 0. This means that I have no remainder left.
Use synthetic division to divide by x minus a. So when we're using synthetic division, we're going to set it up very similarly to how we did long division. It's actually just a more simplified form of long division, okay? This does work with any binomial that you're dividing by, but you have to do a little bit of manipulation if it's anything other than 1x minus a value or 1x plus a value. Okay? We're only going to be dealing with divisors of 1x plus a or 1x minus a. I'm going to set x minus a equal to 0 and solve for x. I'm going to use the coefficients from the terms in your dividend to set up the top row of your synthetic division. So I'm just using the numbers that are out in front. So if I, again, had 3x squared plus 0 or plus 4, my numbers would be 3 and then 4. But you also want to make sure that you've got that 0 in as a placeholder. So if I went 3x squared, no x term, and then 4, I would put 3, 0, and then 4 in my top row. Okay. I bring down the coefficient of my first term. I multiply this number by your x value, my 0. Okay. I add this number to the coefficient of my next term and repeat the process until I've reached the last term and either have a 0 or a number. If I have a 0, it means I have no remainder. If I have a number, that is my remainder. Okay. I write my quotient. Remember that you are going to use an exponent with a degree 1 less than what you started with in your dividend. So if I started with an x to the third power, my quotient is going to have an x squared as my first term. So I'm dividing x cubed minus 2x squared minus 3x plus 10 divided by x plus 5. The first thing that I want to do is figure out the 0 of my function. So I'm going to take x plus 5 equals 0, and I'm going to find that x equals negative 5. This is the number that I'm going to be using to divide my polynomial by. So negative 5 is actually going to go on the outside, and I'm going to take the coefficients of each of my terms in my polynomial in my numerator. So I have 1, negative 2, negative 3, and 10. Now I'm going to bring that 1 down, and I'm going to multiply 1 times negative 5. That gives me negative 5. Now I'm going to add negative 2 plus negative 5, which gives me negative 7. I'm going to repeat those steps. Negative 7 times negative 5 is 35. 35 plus negative 3 gives me 32. 32 times negative 5 is negative 160. Plus 10 gives me negative 150. This is going to give me my final solution of x squared minus 7x plus 32 minus 150 divided by x plus 5. So I'm going to divide 4x cubed minus 3x minus 99 divided by x minus 3. First thing I need to do is figure out my 0. So x minus 3 equals 0, so x equals 3. This is the number that I'm going to be using to divide. So the 3 goes on the outside or in that little box, okay? And then I'm going to set up each of my coefficients. Looking at this, I have x cubed and x, but no x squared, so I need to substitute a 0 in for that. Now I'm going to bring down my 4. 3 times 4 gives me 12. 0 plus 12 gives me 12. 12 times 3 is going to give me 36. 36 plus negative 3 gives me positive 33. 33 times 3 is 99. plus negative 99 is 0. So in this case, I'm not going to have a remainder, but I will get a final solution of 4x squared plus 12x plus 33. Relate p of a to the remainder of p of x divided by x minus a. Example, how can you use long division to divide p of x by d of x? Write the polynomial p of x in terms of the quotient and the remainder. So the first thing I'm doing is I'm dividing x cubed plus 8x squared plus 12x plus 5 divided by x plus 2. So I want to solve that x plus 2 and set that equal to 0. So I get x equals negative 2. So this is the 0 of my function. This is when my denominator, what I'm dividing by, would equal 0. You can either use long division or synthetic division. Either will work. It'll get you the same answer. Okay, that negative 2 is on the outside. Okay, I bring down my 1. Negative 2 times 1 gives me negative 2. 8 plus negative 2 gives me 6. 6 times negative 2 gives me negative 12. 12 plus negative 12 is 0. 0 times negative 2 is 0. 5 plus 0 is 5. Okay, so I'm going to have a remainder of 5. The next thing that I can do is actually set this up. So I've got dividend, the number I was dividing by, equals my quotient times my divisor plus my remainder. Okay, and I want to substitute negative 2 in for my x value and simplify. So the number that I got, right, if we saw this, we would get x squared plus 6x. So x squared plus 6x times x plus 2, the number I divided by, plus 5, my remainder. So negative 2 squared plus 6 times negative 2 times negative 2 plus 2 plus 5. Well, negative 2 plus 2, it gives me 0. Negative 2 squared gives me 4, and 6 times negative 2 gives me 12. 4 minus 12 is negative 8, but anything times 0 is 0. So I'm left with that 5. So p of negative 2 gives me 5. Okay. So when you simplify, you can see that you will get the remainder. The remainder is what I would have left over. The remainder theorem. So the remainder theorem states that if a polynomial p of x is divided by x minus a, the remainder is p of a. So basically, if I put whatever remainder is into my polynomial, I'm going to get 0. Okay? If I multiply the quotient times the divisor, I'm going to get 0. Factor theorem. The factor theorem states that the expression x minus a is a factor of a polynomial p of x if and only if p of a equals 0. So when I solve this, right, when I divide something and I get a remainder of 0, that means what I divided by is a factor. So in the previous cases we've had, where we've had remainders of 5 or remainders of 15, those are not factors, what we've divided by. Okay? So the only way that it is a factor would be if we have a remainder of 0. Use the remainder theorem to evaluate polynomials. The population of sea turtles is modeled by the function p of x equals x cubed minus 6x squared minus 12x plus 325, where x is the number of years since 2015. I want to use the remainder theorem to estimate the population in 2026. So the first thing that I want to do is I want to determine the 0 by subtracting the year that I'm looking for by the year it started. So in this case, I'm looking for year 2026. This graph started in 2015. So 2026 minus 2015 is 11. So I'm looking at 11 years since I started using this function. What would the estimated population be? I use that 11, that 0, in order to divide my function x cubed minus 6x squared minus 12x plus 325. Okay, I set it up as synthetic division. You can, of course, use long division. Either way will work. It'll get you the same answer. Okay, using synthetic division, I'm going to pull those coefficients. So I have a coefficient of 1, -6, -12, and 325. I bring down my 1. 11 times 1 is 11. -6 plus 11 is 5. 5 times 11 is 55. -12 plus 55 gives me 43. 43 times 11 is 473. 325 plus 473 gives me 798. So this tells me there's an estimated population of 798 sea turtles in 2026. Check whether x minus a is a factor of p of x. So I'm going to start with x to the fourth minus 8x cubed plus 16x squared minus 23x minus 6. So my binomial is x minus 6. That's what I'm dividing by. It's my divisor. I find my 0, so x minus 6 equals 0, so x equals 6. And then I can set up synthetic division and solve. So when I do this, I have my coefficients of 1, -8, 16, -23, and -6. I bring down my 1. 1 times 6 is 6, plus -8 gives me -2. -2 times 6 is -12, plus 16 gives me 4. 4 times 6 is 24. 24 plus -23 is 1. 1 times 6 is 6, plus -6 is 0. I can substitute that value back into my polynomial. So 6 to the fourth minus 8 times 6 cubed plus 16 times 6 squared minus 23 times 6 minus 6. So I get 1296 minus 1728 plus 576 minus 138 minus 6. Okay, when I simplify, I'm going to get 0. Since I got 0, this tells me that x equals 6 is a factor of x to the fourth minus 8x cubed plus 16x squared minus 23x minus 6. So it's also a really quick way to see if we have a remainder or not. And whatever number I put in here is going to give me my remainder at the end. So if I have x to the fifth minus 5x cubed plus 9x squared minus x plus 3, and I'm dividing by x plus 3, I'm going to set up and find my 0. X plus 3 equals 0 gives me x equals -3. I'm going to set up my synthetic division and solve. Okay. When I do that, I get a remainder of -21. And just to make sure that this works, right, I'm going to use -3 and I'm going to substitute it in and see if it actually is a factor of this polynomial that I'm dividing. Okay. It is not a factor, so -3 does not go in evenly into this polynomial. Summary. So we have two different ways that we can write our answer to our division problems. So I can write it as the quotient plus my remainder divided by divisor, or I can write it as quotient times my divisor plus my remainder. I have the remainder theorem, the factor theorem, and then I've got my long division versus my synthetic division. And I can also use this to figure out if something is a 0 of a function. And that is the end of lesson 4.